These basalt columns are located in the heart of Central Europe, near Freiberg in Saxony, Germany. They tower 40 meters high, and locally they're called the organ pipes. Today they look calm enough, but 200 years ago they were at the center of a controversy about how the Earth's crust was formed. It was in the 1780s that Abraham Gottlob Werner formalized his new theory that was to have worldwide significance for the new science of geology. And these basalt columns were the key to that theory. This film explores the historical context of Werner's ideas, and in particular the interaction between theory and practice in Saxony. And it provides us with a case study of the emergence of a particular scientific idea. Saxony is bounded to the south by what today we call Czechoslovakia, but in Werner's time was called Bohemia. A vast complex of ore mountains, the Erzgebirge, provided a natural boundary to the south, to Bohemia, and on this side the mountains fall away steeply. But on the Saxon side, especially around Freiberg, the hills are much gentler. Our case study of Werner's theory starts with the plentiful ore deposits of the Erzgebirge. Beneath the Saxon hills, there used to be one of the richest sources of silver in the world, especially in the area around Freiberg. Already by the 16th century, there was a long tradition of silver mining. It was hard and difficult work. The actual technique of removing the silver-bearing ore from the veins was very basic. The miner plus hammer and chisel. It was basic but effective, worked out from practical experience, and it remained the same up into the 20th century when this mine was still worked. Dr. Rainer Sennewald explains the problems the miners faced.
Die Arbeit für die Bergleute unter Tage war sehr beschwerlich. Das Gestein war recht fest hier im Freiberger Revier und es war auch sehr schwierig, die Stellen zu finden, wo viel Erz vorhanden war. Normal war es so, dass der Bergmann sehr viel Gestein herausarbeiten musste, ehe er wenig Erz fand. Diese Strecken sind für das 16. bis 18. Jahrhundert typisch und der Bergmann hat hier allein vor Ort gearbeitet und hat in der Woche etwa 25 bis 35 Zentimeter die Strecke vorgetrieben.
Even silver-rich stone like this yielded only minute quantities of silver, visible here as twisted grey strands. Slow work, but worth it because of the great value of silver. By the 16th century, the culture of silver mining was both valued and wealth-producing, as this Saxon altarpiece, which was completed in 1526, illustrates. The actual mining of the silver may have been a basic technique, but the rest of the process was technologically advanced, a well-established system developed over centuries of practical experience. When the ore was brought to the surface, it was then dressed, broken up into manageable pieces, and then washed and graded, ready for the metal to be extracted from the ore in the smelter's furnaces. This smelting process provided silver metal, which was then made into the object of the exercise, coins of the realm. Practical knowledge was supplemented by a religious element. Here, according to legend, Anna, the patron saint of miners, tells the miner Knapp where to dig for silver. And mystical forces could also be called on to lead the divining rod to silver deposits. "400 years earlier, Duke Otto, the ruler of Saxony, played a decisive role in encouraging mining. He claimed ownership of all underground areas and decreed that in return for paying him a tithe, anyone had the right to mine, regardless of who owned the land above, so giving the town its name, Freiberg, free mountain, or free mining. Shafts were rapidly sunk and the town grew up on top of the silver deposits, and for 4 centuries Freiberg and the rest of Saxony enjoyed unrivaled wealth. But by the middle of the 16th century, the silver deposits near the surface were exhausted. There were good deposits deeper down, but going deeper presented the miners with a problem. Professor Eberhard Wächtler explains.
Das Problem des Erzgebirges ist, dass es nach Süden, nach Böhmen, nach der Tschechoslowakei zu, einen Steilabfall hat, während es sich nach Sachsen zu, das heißt nach Leipzig zu, in einem sehr flachen Winkel abfallen lässt. Das bedeutet für den Bergbau Folgendes, wenn wir uns das so vorstellen, dass man von Böhmen aus vorwiegend mit Stollenbergbau die Erzlagerstätten erreicht, während man auf der sächsischen Seite sehr bald, wenn man die Oberfläche abgebaut hat, mit tiefen Schächten einwirken muss. Diese tiefen Schächte bedingen natürlich dann Technik, Wasserräder, Kraftübertragung, und dazu braucht man ein Energiesystem.
The main problem in the deeper mines was flooding in the shafts and tunnels. The solution was ingenious: to bring yet more water into the mines. The water was collected in a series of artificial lakes and directed down the hillside from lake to lake in specially constructed water channels. This was all built over 400 years ago, in the 1560s, and is still in use today. It may look simple, but it's actually a very sophisticated solution to the problem of drainage. The water channels were carefully dug to control the flow of water, and there is a consistent drop of 1 meter for every kilometer. To achieve this, a precise understanding of the way the land fell was needed, so that its contours could be exploited to get this gentle and controllable flow. When the water reached a mine, it could be directed to a water wheel. This water wheel operated a pump to bring water up from below. In turn, this water could be used to power a further water wheel and pumps lower down. Inside the complex of mines, there was one main water channel, or adit, which ran underneath the whole system. Then, individual channels from each mine fed water into the main adit, with the water often passing through several mines on its underground journey. This vast tunneling system was hewn through solid rock, an amazingly accurate and precise achievement for the 16th century surveyors. This drainage system linked all the mines in the area, and the water channels were also used as tunnels to get about underground. Eventually, the water, which had been used to provide energy, possibly several times, flowed out of the mines. And from here, it could be directed to another mine lower down to start the process all over again. This complete, integrated and sophisticated system covered a vast area around Freiberg.
Dieses System war nur möglich, indem der Landesherr mit seiner Macht dazu die Voraussetzungen schuf. Über 100 Kilometer von Ost nach West und von Süd nach Nord waren es 60 Kilometer. Das bedeutet, dass der grundbesitzende Adel gezwungen werden musste und die Bauern in ihren Wäldern, auf ihren Feldern, Teiche, Kanäle, Bräuchen und anderes zuzulassen.
The ruler of Saxony had guaranteed the future of silver mining, the state's main wealth-producing asset, by this unique technological development. This complex system needed an administration to run it, and in 1542 the ruler set up a mining civil service in Freiberg. It was important in the continuing prosperity of the state, and by the 18th century it was formalized and part of the courtly tradition. The mining civil service had an obvious economic function: to make possible more silver extraction and therefore create more wealth for the ruler. It controlled all aspects of the metal mining process, from surveying the mines to the miners themselves through to the minting of the coins. But an important legacy was its stimulus to technical education, for it required well-trained staff. It was this emphasis on technical training that led to the foundation of the Mining Academy in Freiberg in 1765. The head of the mining civil service wrote to the ruler of Saxony with a plan to regenerate the mines through technical education. Within 10 days of receiving the letter, the ruler authorized the setting up of the Mining Academy and a detailed master plan was drawn up. The speed of the royal response was due no doubt to his desire to reconstruct after Saxony's defeat in the 7 Years' War. Advertisements were placed worldwide for students for this new institute. An early student at the Mining Academy was Abraham Gottlob Werner, attracted there no doubt by his strong interest in mineralogy. He then went to Leipzig to complete his studies, and in 1774 he returned to the Mining Academy as a professor. Today, Freiberg Mining Academy remains an important international center for the study of all aspects of mining. In Werner's day, it was part of a whole movement of mining academies established in Central Europe through the 18th century. There's no doubt that it was a leader in the field, with students coming from all over the world to study there. Werner was professor of mineralogy and mining, as well as being an inspector for the mining civil service. It was this combination of theory and practice that was a key to the developing European mining academies. The academy had a strong economic function, but it was also concerned for the cultural regeneration of Saxony. Werner was working there at a time when ideas of the Enlightenment were spreading throughout Europe. People were eager to learn and considered that all sources of knowledge were equally important. Dr. Peter Schmidt.
Dass Werner in der Tat Teilnehmer an dieser internationalen Entwicklung war, kommt auf sehr verschiedene Art und Weise zum Ausdruck. Belegt kann es werden an Mineralien, aber auch, was die Bibliothek der Bergakademie Freiberg betrifft, an den Büchern aus der Privatbibliothek Werners und an seinen Briefen, die seine Kollegen, Freunde und Schüler ihrem Lehrer, ihrem Kollegen schrieben. Nämlich einmal können wir hier betrachten einen Brief von James Watt, den James Watt Junior, seinem Lehrer 1802 nach Freiberg schrieb, und als zweites Beispiel ein Brief, den 1797 Del Rio seinem Lehrer adressierte. Der Inhalt dieser Briefe ist natürlich sehr unterschiedlicher und vielgestaltiger Art, ist ein Gemisch von persönlichen Dingen, aber natürlich auch von wissenschaftlichen Dingen, insoweit es der Mineralogie, der Geologie, den Bergbau in Sachsen, aber auch in Europa und der ganzen Welt angeht.
Werner taught both mineralogy and mining. In his lectures on metal mining, he emphasized the practical aspects, and he used this working model to give his students practical instruction in the complete working process of the mine. This is an ore dressing station, and we can see the water-powered stamp mill which is used to crush the ore. Then it's washed and graded here on these trays. Werner's teaching was very much based on practical knowledge he'd gained through the mining civil service. The students received a wide range of practical training. This included surveying the mines in the area and also going down the Mining Academy's own teaching mine, the Alte Elisabeth, Old Elizabeth. But within the mine, Werner and the students were also able to extend their theoretical knowledge about geological processes. And unusually for the time, Werner wrote down his developing theories about the origins of ore deposits. He also took every opportunity to learn from the miners.
Die Bergleute haben während ihrer Arbeit im Laufe von vielen Generationen sehr viele Erfahrungen über die Natur der Gänge gesammelt und immer von Generation zu Generation weitergegeben. Wir sind hier an einer Stelle, wo sich zwei Gänge kreuzen. Wir haben einen für die Bergleute sehr wichtigen Gang, der von Nord nach Süd verläuft. Dieser Gang hat viel Erz gehabt. Solche von Nord nach Süd laufenden Gänge haben die Bergleute besonders gesucht. Wir haben aber auch einen Erzgang, der von Ost nach West läuft. Er hat den Namen Glück auf Spat. Diese Gänge hatten nicht so viel Erz, aber sie wurden von den Bergleuten genutzt, um erzreiche Gänge zu finden. Abraham Gottlob Werner hat dann Ende des 18. Jahrhunderts solche Erfahrungen der Bergleute gesammelt. Dazu musste er in die Gruben gehen und hat versucht, das System und die Gesetzmäßigkeiten dieser Erzgänge zu erkennen und aufzuschreiben.
This type of local knowledge was an important key to Werner's practical experience. He didn't travel far from Saxony, and he didn't need to. Not only were the rich mineral deposits of the Erzgebirge close to hand, but students and colleagues from all over the world also sent mineral specimens to him at the Freiberg Mining Academy. A new science, geology, was emerging, and Werner's contribution to it was crucial.
Ich denke in der Tat, Werner war sowohl ein sächsischer Geologe, als auch ein Geologe, der sich mit den internationalen Dingen beschäftigte. Sächsischer Geologe in dieser Hinsicht, dass Werner das Charakteristische unserer Hochschule, der Bergakademie, in seiner Person verkörperte, nämlich die Verbindung von Theorie und Praxis. International würde ich meinen, Werner war ein Geologe unter jenen vielen anderen Geologen unserer Erde, der sich der Beschreibung dieser Erde widmete, der versuchte, die Mineralien und Gesteine zu ordnen, zu systematisieren, sie sprechen zu lassen für seine Studenten, für seine Zeit.
Werner's handbook on the external characteristics of minerals was vital for the definitive identification of minerals. To further help his students, he built up a teaching collection of minerals, still kept today in the Freiberg Mining Academy, so that they could handle them and learn to recognize different minerals through actual practical experience. He divided his collection into categories based on the 5 senses. Here, Brigitte Munn demonstrates how this mineral can be recognized by the sense of touch. It clings slightly to the tongue. And this one can be recognized by the sense of smell. When you rub it, it smells of garlic. Extremely useful information if you were in a dimly lit place underground.
Werner unterschied auch Farben. Rot, Grün, Blau, Gelb, Schwarz zum Beispiel, aber nicht nur die Farben allgemein, sondern er hatte für jede Farbe noch Unterscheidungen. Er hat zum Beispiel gesagt, Blau ist auch Kobaltblau, Lasurblau. Es gibt viele Abstufungen, Nuancen von Blau. Dasselbe bei Gelb oder Grün. Also hat er damit die Theorie, die er in seinen Vorlesungen den Studenten gab, mit Hilfe dieser Sammlung praktisch unterstützt.
It's in his work on minerals that the interaction between theory and practice proves most fruitful. He has practical knowledge of minerals, and he also builds up a theoretical view of their internal features. And from there he considers how and when the Earth's crust was formed. The dominant view was that it was made up of individual rocks and minerals which should all be considered as separate entities. But Werner followed a less accepted line that the key to understanding was to treat the sets of strata in which the individual rocks and minerals occurred as single formations. And from this he developed his controversial theory that all rocks were sedimentary, that they'd all been deposited by water. And it was the sight of these basalt columns and their underlying strata that convinced him that his theory was correct.
Werner schöpfte sein Wissen in der Mineralogie und Geologie natürlich vorwiegend aus dem Gelände, aus seinen Beobachtungen in der Natur und nicht vornehmlich aus Büchern. Diesen Anspruch stellte er sowohl an sich selbst als auch an seine Studenten. So hielt er es Jahr für Jahr und auch im Jahre 1788 fuhr er mit 5 oder 6 Studenten hier in das Erzgebirge, um hier an diesem Scheibenberg die geologischen Verhältnisse zu untersuchen und seinen Studenten zu erklären. Wenn wir nach der Wichtigkeit, nach der Bedeutung jener Dinge fragen, die Abraham Gottlob Werner hier vorfand, so müssen wir nur in seinen Schriften nachsuchen. Und im Bergmännischen Journal von 1788 finden wir dazu auszugsweise etwa Folgendes. Ich möchte das einmal vorlesen. Zitat. Wie erstaunte ich aber, als ich hinkam, hierher, und gleich mit einem Blicke...
How astonished I was when I came to this place, and with one glance I took everything in. First, at the bottom, I saw an immense layer of sand and gravel. Above that, some clay layers. And then a layer of wacke, a kind of friable basalt. And finally, lying above that, the basalt. And I knew without any doubt that the basalt, the wacke, the clay, and the sand and gravel were all part of one formation, and that they had all been deposited here by water at one and the same time, when this region had been covered by an immense flood.
Aus einer und derselben ehemaligen Wasserbedeckung dieser Gegend entstanden. Dass diese Gegenden
The water that covered this area first deposited sand here. Then clay settled on top of this. Then, little by little, the clay altered into a precipitation of wacke, and finally into a precipitation of true basalt.
Although Werner's theory that all rocks were laid down by water was later shown to be mistaken, his methodology and his approach to the study of the Earth's crust were of lasting importance. He formalized the principle of the succession of strata over time as the key to the study of geology.
Werner hat natürlich seine Zeit und auch die nachfolgenden Jahrhunderte maßgeblich beeinflusst. Gewiss war nicht alles richtig, was Werner sagte, lehrte und schrieb. Wenn wir nach der Bedeutung Werners fragen würden, so gäbe es eine Fülle von Dingen zu sagen. Hervorheben für bemerkenswert halte ich in etwa folgende Tatsachen. Abraham Gottlob Werner war über 40 Jahre Lehrer an der Bergakademie Freiberg und trug Wesentliches dazu bei, dass diese Hochschule international bekannt wird. Abraham Gottlob Werner hat im Verein mit anderen Geologen seiner Zeit die Mineralogie und Geologie sehr befördert, diesen Wissenschaften Impulse verliehen. Ja, man kann sagen, zu Recht sagen, Abraham Gottlob Werner gehörte zu den Mitbegründern der Geologie und Mineralogie.
Werner's importance for geology was his theoretical approach to this new science, an approach strongly rooted in his Saxon experience, including the technological developments around Freiberg. Werner found the mix of theory and practice in Saxony a stimulus for the development of his scientific ideas. But those ideas went beyond the Saxon context, for he was also part of a wider circle at the forefront of new scientific thinking in the 18th century.